All right, welcome back to the deep dive. Today, we're going to be diving into something pretty interesting. It's all about TLS fingerprinting.
Okay.
Now, most of you are probably familiar with that little padlock icon you see up in your browser window, the one that tells you, hey, this connection is secure.
Right.
But what you might not realize is that the very process of creating that secure connection, that initial handshake between your device and the website, actually spills a whole lot of unique information about, well, you and your device.
Yeah, that little handshake can be pretty revealing.
Exactly. And so today we're going to explore why this even matters to you. Whether you're, getting ready for a big security meeting at work, or just trying to wrap your head around the latest tech, or maybe you're just curious about how the internet tries to, keep things locked down and safe, we're going to break it all down.
Sounds good.
So to really dig deep into this, we've been looking at this really interesting guide for security engineers. It was published by Rebrowser pretty recently, actually just earlier this year, 2025.
Oh, wow, cutting edge.
Yeah, and it goes way beyond just the basics. It really gets into the more advanced ways that TLS fingerprinting is being used these days, and all the I guess you could say the hurdles that folks are running into when they're trying to implement it. So our goal today is to, pull out the most important takeaways from this guide and really help you understand, what exactly is TLS fingerprinting? How does this thing actually work? And why is it so important in the world of cybersecurity today? And, what's the state of the art? Like, what's the cutting edge of this technology look like right now?
All right, well, let's get into it. What is this TLS fingerprinting thing anyway?
Yeah, let's break it down. So what is TLS fingerprinting?
So in a nutshell, it's basically a way for servers to figure out exactly who's connecting to them, like what specific device, and they can do this even before any actual data is exchanged.
Oh, interesting. So before anything is even sent back and forth.
Exactly. It's kind of like recognizing someone by the way they greet you, before they even say their name. You can kind of tell who it is just by their style, their mannerisms.
Gotcha. So it's like a digital handshake.
Exactly. And this identification all happens during the very first step of setting up that secure connection. It's called the TLS handshake. And specifically, it's looking at the initial message that your device sends out. It's called the client hello.
Oh, okay. So it's not just looking at like the obvious stuff, like, what browser I tell the website I'm using, or even my computer's IP address, right?
Those are things like the user agent string or
Yeah.
your IP address, which, as you probably know, those can be pretty easily faked,
Right.
spoofed. But TLS fingerprinting goes much deeper.
Yeah.
It's looking at the actual, the cryptographic capabilities and the preferences that are kind of baked into your device and its software. So it's a much more reliable way to figure out who's who, especially when you're trying to spot those automated tools that are trying to pretend to be real users, like the ones that are used for web scraping.
Right.
And the guide really dives into how effective this can be at actually protecting against these kinds of automated threats.
So it's not just about knowing who's connecting, it's about figuring out if they're who they say they are.
Yeah, exactly. It's all about making sure the good guys get in and the bad guys stay out.
Makes sense. So it sounds like this isn't a brand new concept, this TLS fingerprinting, but it's definitely come a long way, right?
Oh, absolutely. In the early days, it was pretty simple. Basically, they were just comparing a client's configuration to a list of known signatures, kind of like a wanted poster for certain types of software.
Oh, I see. So they had a list of bad guys, basically.
Exactly. But as technology has evolved, things have gotten a lot more sophisticated, especially in recent years.
Makes sense.
The biggest game changer has been bringing in machine learning and behavioral analysis.
Oh, okay.
So instead of just looking for an exact match to a known fingerprint, these modern systems can actually pick up on patterns and unusual activity in the way that clients negotiate their secure connections.
I see. So they're looking for things that are out of the ordinary, not just things that they've seen before.
Exactly. It's all about finding those subtle clues that might point to something fishy going on.
Oh, that's really cool. And that's going to make it way more effective, right?
It really does. In fact, the guide mentions some research from Usenix Security back in 2023 that showed that these modern TLS fingerprinting systems can be up to 94% accurate at spotting automated traffic.
Wow, 94%. That's huge.
Yeah, it's a massive leap forward. And it really shows how these advancements have made it much more practical.
Yeah.
It's not just a theory anymore. It's a real tool that people are using to protect themselves.
So it's gone from a simple fingerprint match to something that can actually analyze behavior and make predictions.
Exactly. It's become much more intelligent and proactive.
That's awesome. Okay, so we've talked about what TLS fingerprinting is and how it's changed over time. Now let's get a little bit more technical. Can we talk about how it actually works? You mentioned the TLS handshake earlier.
Yeah, the handshake.
What's going on there?
So that TLS handshake is the initial conversation between your device, the client, and the website server.
Okay.
It's what they do to set up that secure action,
Okay.
make sure they can talk safely. And it all starts with that client hello message that we talked about. It's basically your device saying, hey, here are all the ways I know how to communicate securely. It lists things like the different versions of TLS, which is transport layer security, that it can use.
Okay.
Its preferred methods for encrypting the data, those are called cipher suites.
Cipher suites.
Yeah. And any special features that it supports, those are called extensions. And then its preferences for application layer protocols and the types of elliptic curves that it can use for cryptography. It's a whole package of information about how it likes to secure things.
So it's like a resume for your security skills.
Yeah, exactly. Like, here's what I can do. Let's find a way to work together securely. And then the server responds with its own server hello message.
Oh, okay.
And it basically picks the security settings that both sides can agree on.
Right, so they find some common ground.
Exactly.
So the fingerprint itself isn't the whole back and forth. It's specifically what's in that first client hello message, right?
Exactly. The TLS fingerprint is built by looking at all the details packed into that client hello message.
Gotcha.
Like, for example, the order in which your device lists those preferred cipher suites.
Okay.
Different browsers and operating systems, they tend to have their own unique preferences for how they order things.
Interesting.
Yeah. And then the range of TLS versions your client can handle, that's another piece of the puzzle.
Okay.
And then there's those TLS extensions that we talked about.
Right.
Those are the optional capabilities that a client might ask for or say it supports.
Okay.
And the specific set of those extensions and the order they're in can be really telling.
Oh, wow.
And then you've got things like your device's preferences for ALPN.
ALPN.
Yeah, application layer protocol negotiation. It helps decide which application protocol to use over that secure connection, things like the newer HTTP2.
Okay.
And the elliptic curves it supports for all the cryptography stuff. All these things add up to this unique fingerprint. It's like everyone has their own little way of introducing themselves in this secure conversation.
Oh, I like that analogy. It's like a digital dialect almost.
Yeah, you got it.
So we've got all these little details that make up the fingerprint. Now, you mentioned something earlier called JA3.
J3.
What is that all about?
J3, that's kind of the gold standard when it comes to TLS fingerprinting.
Oh, okay.
It was created by Salesforce, and it's a way to create these fingerprints in a consistent and easy to understand way. It's like having a shared language to describe these unique client configurations.
Oh, so it's like a universal translator for TLS fingerprints.
Yeah, exactly.
Yeah.
And make sure everyone's speaking the same language when it comes to these fingerprints.
That's really cool. So how does JA3 actually work? What does one of these JA3 fingerprints actually look like?
So the JA3 standard has this very specific method for taking all those key ingredients from that client hello message, the TLS version, the list of cipher suites, the extensions, elliptic curves, all that stuff, and it combines them all into a single text string, all separated by commas.
Okay.
And then they apply this cryptographic hash function called MD5 to that string.
MD5.
Yeah, and the result of that is the JA3 fingerprint.
Gotcha.
And the guide actually gives a really clear example. So a client might present all its TLS capabilities in a way that looks like this string. And it's a long one. It's like 771,465, 4867, 4866, 49195, and it keeps going. But the point is, when you run that whole string through the JA3 algorithm, you get a specific MD5 hash. And in that example, it's 579CC, 31D, 8482C, VC42, D2B, A2D2, CT2480.
Okay.
So all these letters and numbers, they become the unique identifier for that client's TLS configuration.
So something that looks like total gibberish to me actually tells you a whole lot about the device making the connection.
You got it. It's all about translating that complex handshake into something that security folks can easily understand and use.
That's amazing. So now that we have this standard JA3, how are companies actually using TLS fingerprinting to, beef up their security today?
Well, the guide highlights a few key ways. One is something called hybrid detection. It's basically combining that old school method of matching against a database of known bad fingerprints with more advanced machine learning analysis.
Okay.
So it's like having the best of both worlds, the known bad guys, and the ability to spot new emerging threats.
Right. So they're not just relying on what they already know. They're using AI to learn and adapt as new threats pop up.
Exactly. And then another approach is real-time analysis.
Okay.
This is where organizations are using these distributed systems to process these fingerprints as they happen, instantly. So they can react super fast to potential attacks.
Wow. So they're analyzing everything on the fly.
Yeah, it's like having a security guard that can see everything happening in real time and make decisions in a split second.
That's impressive.
And then there's something called adaptive thresholds.
Okay.
This is where they adjust how sensitive their detection mechanisms are based on the traffic patterns they're seeing and the overall risk level.
I see. So they're not just setting it and forgetting it. They're constantly adjusting it to make sure they're not blocking legitimate users.
Exactly. You don't want to be too aggressive and accidentally lock out the good guys.
Yeah.
It's all about finding the right balance.
Right. Finding that sweet spot between security and usability.
Exactly.
Now, speaking of real-world examples, the guide mentions a really interesting case study about this big e-commerce platform. Can you tell us a bit about that?
Yeah, this was a fascinating one. It was a huge platform, over 50 million users a month, and they implemented TLS fingerprinting back in 2023 specifically to combat automated attacks, things like credit card testing and account takeovers.
Oh, wow. So they were dealing with some serious threats.
Yeah, they were. But it took them about 3 months to get the system up and running, and they really put a lot of effort into fine-tuning it so it wouldn't cause problems for their real customers. And after 6 months, the results were pretty amazing. They saw a 47% drop in those credit card testing attempts and a 62% decrease in account takeover attempts.
Wow, that's a huge improvement.
It was. But what was really cool was that they could actually trace back specific attack patterns to certain fingerprint groups.
Oh, wow.
They had a level of visibility they just didn't have before.
So they weren't just stopping the attacks, they were learning about where they were coming from.
Exactly. It was like putting a face to the enemy. And on top of all that, they had a very low false positive rate, just 0.1%. So almost none of their real customers were wrongly flagged.
That's incredible. So they managed to seriously boost their security without impacting their users. That's a huge win. Now, how does this kind of technology actually fit into the day-to-day work of a security team?
Well, more and more, security operations centers, SOCs as they're called, are making TLS fingerprinting a core part of how they detect threats.
Okay.
They use it for things like bot scoring systems, constantly analyzing millions of connections every single day. And to handle that kind of volume, they have to rely on distributed computing and real-time analytics platforms.
Right.
It's a lot of data to crunch. And the guide actually lays out the typical steps involved. First, they capture the network traffic and pull out those TLS fingerprints. Then they run those fingerprints through a whole battery of tests,
Okay.
matching them against lists of known bad fingerprints, using machine learning to spot weird patterns, even looking at what the connection does after the handshake to see if it's acting suspicious.
So it's not just about the fingerprint itself, it's about the whole context of the connection.
Exactly. And then, based on all that analysis, they give the connection a risk score, and finally, they decide what to do. They might just let it through, or they might make the user jump through some hoops, like a cheap TCHA, or if it's really risky, they might just block it altogether.
Right, so it's like a multi-layered approach, not just a simple yes or no.
Yeah, it's all about using all the information available to make the best decision.
That makes sense. Now, I'm guessing, like any security measure, there's got to be some limitations and challenges with TLS fingerprinting.
Oh, for sure.
What are some of those?
Well, on the technical side, one of the big ones is false positives.
Okay.
That's where legitimate traffic gets mistaken for something malicious.
Right.
It can happen if someone's using a less common device or a weird network setup.
Okay.
And then there's this thing called cipher stunting.
Cipher stunting.
Yeah. This is where attackers mess with their TLS settings on purpose, either to try and blend in with the normal crowd or create a completely new, unknown fingerprint that isn't in anyone's database yet.
Oh, so they're trying to fly under the radar.
Exactly.
All right.
And then, of course, there's the impact on performance, especially for systems that handle a ton of traffic.
Right.
Analyzing every single handshake, it takes some computing power, so it can slow things down a bit.
Yeah, that makes sense. And what about the attackers themselves? Are they evolving their methods to try and get around TLS fingerprinting?
They are. It's a constant arms race. The guide talks about some emerging threats, things like dynamic TLS libraries.
Dynamic TLS libraries.
It lets attackers constantly change their TLS settings on the fly, so it's hard to get a consistent fingerprint on them.
Oh, so they're making it harder to track them.
Exactly. And then there's protocol emulation. This is where really skilled attackers try to perfectly mimic the TLS handshake of a legitimate client.
Wow, so they're basically trying to impersonate the good guys.
Exactly. And it's getting more sophisticated all the time. We're even starting to see the use of machine learning to pick TLS settings that are less likely to raise any red flags.
Oh, wow. So the attackers are using AI too.
Yeah, it's an AI battle out there.
It's like a digital spy versus spy.
Yeah, you could say that.
So where do we go from here? What does the future hold for TLS fingerprinting?
Well, things are definitely still evolving. The guide points to a few areas to keep an eye on. One is the development of quantum-resistant TLS algorithms.
Okay.
That's going to be huge as quantum computing gets more powerful.
Right, we need to stay ahead of the curve.
And then there's this trend of integrating fingerprinting more tightly into what's called zero-trust security models.
Zero trust.
Yeah, that's where every connection, no matter where it's coming from, is treated as potentially dangerous until it proves otherwise.
Oh, so it's like trust no one, verify everyone.
Exactly. And of course, all the advancements in AI and machine learning, they're only going to make fingerprinting and detection more accurate and adaptable.
So it's going to keep getting smarter and more effective. That's good to hear. So for someone listening who's thinking, hey, maybe I should be using TLS fingerprinting in my organization, what are some of the best practices they should keep in mind?
The guide gives some really solid advice. First, keep your fingerprint databases up to date. You got to make sure you're recognizing both the good guys and the bad guys accurately as software changes.
Right, so it's not a set it and forget it kind of thing.
Nope, you got to stay on top of it. And then finding that balance between security and usability, that's crucial.
Right, you don't want to make it so secure that no one can use it.
Exactly. You got to fine-tune those detection rules so you don't block legitimate users by accident.
Okay.
And then performance optimization, making sure it doesn't bog down your systems. That's important, especially for high-traffic sites.
Right.
And of course, you always got to be aware of any compliance rules and privacy laws that might apply to all this data you're collecting.
Yeah, that's a good point. We can't forget about the legal stuff.
Absolutely. And one more thing the guide mentions, TLS fingerprinting. It works really well when you combine it with rate-limiting strategies. It's like a 1-2 punch for your security.
Oh, interesting. So it's not just a standalone solution, it's part of a larger security strategy.
Exactly.
Now, the guide also shares some insights from developers who actually work with TLS fingerprinting. What are some of the things they're observing out in the field?
Well, one thing that security engineers often bring up is that there's always going to be a trade-off between security and usability.
Okay.
If you make your fingerprinting rules too strict, you might end up blocking legitimate users who just happen to have a less common setup, and that can hurt the user experience.
Yeah, no one wants to be locked out just because their device is a little different.
Exactly. And then there's this kind of counterintuitive thing. Sometimes trying too hard to hide your TLS fingerprint, like by randomizing everything, can actually make you more noticeable.
Oh, interesting. Why is that?
Well, because it stands out from how normal traffic usually behaves. It's like trying to blend in by wearing a clown suit.
Oh, I get it. So sometimes trying to be too stealthy just makes you stick out even more.
Exactly. So the general consensus among the experts is that for most legitimate applications, it's best to stick with standard TLS libraries and common configurations.
So don't try to reinvent the wheel, just use what works.
Yeah, keep it simple and follow the best practices.
Good advice. Now, what other challenges do developers face when they're working with TLS fingerprinting?
One of the big ones is keeping those fingerprint databases accurate and up to date.
Okay.
New versions of browsers, operating system updates, changes to TLS libraries. They're all constantly changing the game.
Yeah, it's a moving target.
It is.
Yeah.
So you need a system for constantly monitoring those changes and updating your detection rules.
Makes sense.
A lot of organizations are now using automated systems to help them do that.
Oh, okay. So AI is helping out on the defense side too.
Exactly. And then there's that constant challenge of balancing security and user experience that we talked about.
Right.
You got to be really careful not to block legitimate users while you're trying to catch the bad guys. A lot of times, that means using something called a graduated response.
Graduated response.
Yeah, where suspicious connections get flagged for closer inspection instead of being blocked right away. It's like giving them a chance to prove they're not up to no good.
I see. So it's a more nuanced approach.
Yeah, you got to be smart about it.
So it definitely sounds like a complex and constantly changing field, but a really important one for security.
Absolutely.
So as we wrap up our deep dive here, what are the key takeaways you think our listeners should remember about TLS fingerprinting?
Well, I think the main points are that TLS fingerprinting is a really sophisticated way to identify clients based on all the unique little details of their TLS handshake.
Okay.
And it's become a crucial tool for catching bad guys, especially with the help of machine learning.
Right.
But it's not a silver bullet. There are challenges, like false positives and the fact that attackers are constantly coming up with new ways to evade detection.
Right.
So you got to have a well-thought-out strategy if you're going to use it, one that balances security with a good user experience.
Makes sense.
And you got to stay vigilant, keep those systems up to date, and be ready to adapt to whatever the attackers throw at you.
That's good advice. So when you think about how much information is hidden in that seemingly simple handshake, it really makes you wonder, what other little digital interactions might be revealing more than we realize?
Yeah, that's a great point.
It's definitely something to think about. And for those of you who want to go even deeper down the rabbit hole, the Rebrowser guide has some great links to the JA3 GitHub repository and the technical specs for TLS 1.3 and 1.2.
Yeah, those are great resources.
We encourage you to check those out. Thanks for joining us for this deep dive,
Thanks for having me.
and we'll catch you next time.